Let's look at this question. We are still on our WASSCE 2024. This is question 11b, called mass. It said the graph of the relation y is equal to s squared plus bs plus c, where b and c are constant. Cut the s axis as 3 and the y axis at 6. Find the values of a and b. Use the values of b and c to solve s squared plus bs plus c equal to 0. Quadratic. Alright, so we are given the quadratic function here as y is equal to s squared plus bs plus c. And he's saying that b and c are constant, and the graph cuts s axis at 3 and y axis as what? At 6. So because this is quadratic, when you have the graph, you are going to get what? A curve. Alright, and let's look at the nature of a curve. See, anytime the coefficient of the s square of the quadratic function, okay, is positive, then what it means that you are going to get a minimum curve. Okay, a minimum curve like this. Your curve is going to be minimum. Alright, your curve is going to look like this. But anytime the coefficient of the s square is positive, then your curve is going to be maximum like this. Alright, curve is going to look like this. So when you look at the question, what we are given, y is equal to s squared plus b plus c, it means that our curve is going to be minimum like this. Alright, so let's see what is going to happen. He's saying that the curve cuts the s axis at 3 and the y axis at 6. So if our curve is going to be minimum, then it will be something like this. Alright, where this is our y axis and this is our s axis, it will cut the s axis at 3. Let's say maybe my 3 is here, or it can be here. And the y axis at what? The y axis at 6. So maybe the 6 is going to be here. So it is cutting the s and cutting the y axis. Alright. So what is we are going to happen? So it says when you look at the curve, you see the nature of it. It can happen that the curve can even be like this. Cut the s axis just at a point. Alright, and here will be 6. If the curve is like this, then what it means is that we have what? The function of the quadratic is what? Is a perfect square. Alright, where we will have equal roots. Okay, equal roots where the values of the s will be the same. We can also do like this. Because actually we don't know the other value of the s. So the s values are going to be 2. But we're giving just 1, so it can either be like this, where we may have another s value that is different roots, or we may have equal roots. Okay, equal roots may be like this, maybe s minus 3 all squared, where the quadratic function may be like s squared 3 times s times 2 minus 6s plus 9. So when it happens like this, okay, where maybe the b is negative 6 and the c is 9, then we are going to have equal roots, where when you solve, you may get s minus 3 and s minus 3, where you have only one, the roots are going to be equal. It means that they are all at the same what? At the same place. Or it can happen that we may have a different root. Alright. So that is that. So our curve, let's come back to the curve again. Our curve is cutting the s axis at what? At 3. And see, on the s axis, on this particular point, what is the value of this particular point will give me 3 or 3, 0. It means that on the s axis, okay, the y value is 0 on the s axis, because every point on the s axis y becomes a y is 0. Y is 0 here. Any point here, y is 0. Let's look on the y axis. On the y axis too, s is 0. So this particular point gives me 0, 6. Alright. So it means that on the s axis we are going to get our point 3, 0, and on the y axis we are going to get our point 0, 6. Okay, so what we are going to do is that we are going to substitute these values into the quadratic function so that we can solve for the values of b and c. Alright, so let's do that. Okay, so what we are going to say is that if the curve cut the s-axis at 3, it implies we have 0.30. Okay, so if the curve cut the s-axis at 3, then we have at that particular point is 0.30. So we are going to substitute, therefore we are giving y is equal to s squared plus bs plus c. So we are going to substitute s and y into the quadratic function. So what is the value of x? 3, y is 0. So 0 will be equal to what? 3 squared plus b multiplied by 3 plus c. So our 0 will be equal to 9 plus 3b plus c. Alright, so let's take the 9 here, so that we are going to have what? Negative 9 is equal to 3b plus c. Okay, so let's put this one down as our equation 1. Then let's go to the second one. If the curve cuts the y-axis at 6, then what are we going to have? We are going to have point what? 0.6. So what do we say? That if the curve cuts the y-axis at 6, then we have point 0.6. Okay, because on the y-axis s is 0, so we are going to have 0.06. So let's also try and substitute into a quadratic function. So it implies that wherever we see x, we will substitute 0, and wherever we see y, we substitute 6. So we have 6 to be equal to 0 squared plus b multiplying 0 plus c. So this one is 0, this one is 0. And our c, 6 is going to be equal to what? C. It implies that c is equal to 6. So we have gotten our c to be equal to what? To be equal to 6. Okay. So if the curve cuts the s-axis at 3. So we have gotten our c to be equal to what? C to be equal to 6. If c is equal to 6, let's come to our equation 1. Our equation, we said what? 3b plus c equal to negative 9. So that I have 3b plus what is the value of 6? C, 6 equal to minus 9. So 3b is going to be minus 9 minus 6. And 3b is going to be minus 15. And my b minus 15 divided by 3 will give me what? Will give me negative 5. So my b is going to be negative 5 and my c is going to be 6. So we can say that therefore b is equal to negative 5 and c is equal to what? C is equal to 6. So our b is negative 5 and our c is 6. Alright, so that is what we have. So simple. Okay, so let's come to the b. Use the value of b and c to solve s squared plus bs plus c equal to 0. So our b is negative 5, our c is 6. So in the question b, what are we going to have? We are going to have, we have s squared plus bs plus c equal to 0. So we are going to solve this quadratic equation by substituting the value of b and then c. So our quadratic equation becomes s squared minus the b is 5s plus 6 equal to 0. So we are going to solve this quadratic equation. And if you observe, I've taught this. This was my first lesson I taught on my channel was quadratic, because I knew that wherever we go, we are going to get quadratic with most of our questions. Okay, so if you understand the nature of quadratic, then it will be easy to solve this particular question. So we multiply the coefficient of the s squared by the constant. So 1 times 6, 6. Then we find two factors of 6. When you add, you are going to get negative 5. So what are the two factors? That will be minus 3 minus 2. Okay, minus 3 times minus 2 give me positive 6. Minus 3 plus minus 2 will give me negative 5. So we are going to split the negative 5 by negative 3 and negative 2. Alright. So we are going to have s squared minus 3x minus 2x plus 6 equal to 0. So that minus 5 will be negative 3s minus 2s. Alright, so that we will what? We will factorize. So we factorize s out, then we have x minus 3 here. Then here to factorize minus 2 out, then you have x minus 3 equal to 0. Alright. So that when you expand, you get the same thing. S times x, s squared, s times s minus 3s, minus 2 times s minus 2s, minus 2 times minus 3 plus positive 6. Okay, so we have x minus 3 and then x minus 2 equal. So we factorize s minus 3 out and we have x minus 2 here. Alright, so we have either s minus 3 is equal to 0, where s equal to 3, or s minus 2 is equal to 0, where s equal to 2. So the values of s is either s is equal to 3 or s is equal to what? S is equal to 2. So we have these two values of s. Alright. So realize that at the beginning, I was telling you that when you draw the graph of this relation, okay, looking at the nature of the question or how it cut the s as a 3 and the y as a 6, what is going to mean is that we are going to have what? These are different roots, not equal roots. So if, okay, I'm drawing the graph for this particular quadratic function here, s squared minus 5x plus 6, okay, then this is how it's going to be. This would have been like this. Our graph would have been like this, where it will touch the s as at 2 and it will touch it at 3, because 2 and 3 are the roots, and then to touch the y at 6, so our graph would have passed here and also pass here. So okay, this would have been how our graph was going to, or is going to be. It will touch, it cuts the s as the y as a 6 and the s as 3. So because the roots are 3 and 2, it will also touch the s as what? At also 2. I believe you have enjoyed and you have understood the question very well. I will see you once more. Bye bye.